Say it again. Yeah, go ahead. Keep going.
AB and BC and CD and DA are all the same.
Perfect. That's a perfectly good conjecture, right? To say that AB is congruent to BC, is congruent to CD, is congruent to AD, right? And remember, when we use the line segment bar, we have to use the congruent symbol. When we don't use the line segment bar, we use equal, because equal we talk about numbers, congruent we talk about shapes. Okay? So that's a perfectly good conjecture to say that's a good conjecture off of this information. What would be like another one? Another conjecture, yeah. Yep, BC and CD meet at a right angle. And we could say that about any of those sides, right? Because it's a square, we know those are right angles. So those are examples of true conjectures based on this statement.
Is that
Right. AD, yeah. Okay. Because this is what we did last time. We talked about conjectures and then counterexamples, where given in a statement, give me an example where that's false, right? Those are all good conjectures. That's what we talked about last time. So that would be the example of the first part of the quiz we'll have next class. Okay. Today we're talking about several different things, but it's a section on logic. The first three things we need to know what they are a statement, a truth value, and a compound statement. Okay, what a statement is just any sentence that's either true or false. You make a statement about something, that statement can be true or false. Right? So we're going to be finding what we call truth values of these statements. What a truth value is it's the truth or falsity of a statement. What that means is it true or false? Right? That's a fancy way of saying what's a truth value. You just tell me, is it true or false? Okay? And a compound statement is two or more statements joined together. Okay, multiple statements joined together. That's a compound statement. We're also going to talk about something called truth tables. Like I said, this section is a tad longer, but it's because we got so many new things to talk about. But we have statement, it's just either true or false. A truth value just means tell me is it true or false. And a compound statement is two or more statements that are put together. Now, there's two types of compound statements that we're going to talk about. We're going to get to those in just a second. They're called conjunctions and disjunctions. Okay, we'll talk about those in just a second. Questions on this at this point right now? And we join them together by either the word and or the word or. Okay, we'll talk about the difference between those two in a second. So then we have something called a negation. Okay, what a negation is we represent statements by P. So for example, let's say I said the statement P is every animal has 4 legs. No, you don't have to write down these examples. Okay, because we got some more coming up. So this is statement P. Every animal has 4 legs. The negation of P we use by this little squiggly in front. It's called a tilde, right? The negation of P is the not P of that statement, or basically the opposite of that statement. So if statement P is every animal has 4 legs, the negation of P would be every animal, well, just the opposite of this, does not have 4 legs. Have 4 legs, right? So statement P is every animal has 4 legs. The negation of P is every animal does not have 4 legs. That's what this little symbol means, this little tilde in front. So we're going to see this symbol a lot. It means not P, okay? Or the opposite of P. So like, which of these statements are true, P or the negation of P? The negation of P is true in this case, right? Because every animal does not have 4 legs. That's true. The statement P itself is false. The truth value of this statement is false. The truth value of this statement is true. That's what that little squiggly in front means, the tilde. It's the negation. Okay. The first type of compound statement we have is called a conjunction. A conjunction is a compound statement with 2 or more statements and the word and. And we use that by this symbol here. Isn't this called a caret, right? Okay. That's an upwards pointing caret. Okay. That means the word and. So like, for example, if I said P is every animal has 4 legs. and statement Q was all I can't think.
Everyone has hair.
Okay, everyone, yeah, has hair. So the compound of this statement, or the conjunction of this statement, would be P and Q. It would be every animal has 4 legs, and everyone has hair. And that's represented by this symbol here. So when you see this symbol, that means the word and. Because we also have a downward pointing arrow, which means something else. So that's called a conjunction. Conjunction means the word and. Okay, and then we're going to talk about the truth values of conjunctions and disjunctions. We know both of these statements themselves are false, right? Statement P is false, statement Q is false. So that means if we put them together with the word and, is it false or true? Well, it's false, right? Because every animal has 4 legs and everyone has hair. That's a false statement. That's a false compound statement. Okay. Again, we use this little symbol. That means the word and. Okay. That's how we tell the difference between a conjunction and a disjunction. We'll talk about it in just a second. So, for example, here's 3 different statements. Statement P, statement Q, and statement R. It says write the conjunction P and Q, then find its truth value. So I'm looking at P and Q. I need to write the compound statement. So that would be 1 foot is 14 inches and September has 30 days. Right? That is the conjunction between P and Q. And then it says, then find its truth value. For a conjunction to be true, both of these things must be true because I used the word and, right? Is the first part true, 1 foot is 14 inches? No, that's false, right? How about the second part? Is it true? Yeah, September has 30 days. So the truth value of this entire statement would be false because I used the word and. Both of these are not true, so the truth value would be false. This is my conjunction. 1 foot is 14 inches and September has 30 days. That is false because the first part is false. Since I used the word and, both of those statements have to be true in order for the whole thing to be true. Okay. We see how that works with a conjunction? That statement itself, the truth value of that entire compound statement would be false. Here I want to write this conjunction and then find its truth value. So what does this symbol in front of this P mean again? Yeah, Dal. Right, the negation of P. So instead of 1 foot is 14 inches, it would be what? Right, 1 foot is not 14 inches. And then this symbol means and. Statement R, which is a plane is defined by 3 non-collinear points.
But we would not put it. Oh, no. So if the R had the little wiggly thing before it?
Right. The negation is only for P, not for R in this case. Right. Good question. So it says, then find the truth value. So is this statement true or false? Now, since I used the word and, both of them have to be true for the whole thing to be true. So first, 1 foot is not 14 inches. That's true, right? And a plane is defined by 3 non-collinear points. Remember, that's how we name a plane, is 3 points on the same line. So the truth value of this statement, or this conjunction, would be true.
But you already said that
The negation of P is true, right? 1 foot is not 14 inches. That's true. But this time I used R. Now I used R, which is this statement. I didn't even use Q in this statement. So this part is true, and this part is true. So the truth value of the whole thing is true. Okay. All right, let's look at another one. Here, I want to find the truth value for P and R. So look at that. Think to yourself, what is the truth value of P and R? So P and R. P is June is the 6 months of the year, and a turtle is a bird. Well, the first part is true. The second part is false. Since I used the word and, the truth value of the whole thing is false. Okay? Is false. Because I used the word and. Now, how about this one? I want you to think to yourself, this is the negation of Q and the negation of R. Is that true or false? Don't shout out. Let everybody give it. Careful. Because,
You said the Q, oh, I thought
yeah.
it said P.
The negation, right, the negation of Q, it would be a square does not have 5 sides. That is true. And the negation of R, a turtle is not a bird. That is also true. So together, the compound statement would be true. Because both of those things are true. Right?
Yeah, I just like this.
Now, the opposite of a conjunction, or I guess the opposite, is called a disjunction. And now it has a caret pointing downwards. So you have to know the difference because a lot of times you will just be given the symbol, either the caret upwards or the caret downwards. The caret downwards is a disjunction. The difference is a disjunction means the word or, okay, instead of the word and, like a conjunction. So this is the other type of compound statement. You can either make a compound statement with the word and, or you can make a compound statement with the word or. When we use or, we use a disjunction, and it has the caret pointing downwards. So this says P or Q, okay, instead of and. Okay, so this says P or Q, okay, instead of the word and. That we call a disjunction. Or instead. So let's take a look at one of those. In this case, okay, this says find the truth value of P or Q. So that's P or Q. That says AB is the proper notation for line AB, or centimeters are metric units. Now, let's take them individually. This first part, AB is the proper notation for line AB. Is that true or false? Be careful here. That's false because this is line segment, right? Line would have arrows on the end. Okay. How about this part? Centimeters are metric units. Remember, you have metric and standard. Standard are things like inches, feet. Metric are things like centimeters, meters, kilometers.
Oh, yeah, sure.
That's true. So since I want the truth value of P or Q, unlike conjunctions where they both have to be true, since I use the word or, only one of them has to be true. So that means the truth value of this P or Q is true because one of them is true. That's because I used the word or. I didn't use the word and.
So if both of them are false, then you would be right.
It would be false. Right. If both were false. Good question. Yeah. Now, again, I'll repeat it one more time. For a disjunction, only one of them has to be true for the whole thing to be true because I used the word or, either this or that. Right? For a conjunction, both have to be true because a conjunction uses the word and. Okay. Let's look at another here. I want Q or R. Q or R. I want the truth value of that statement. So think to yourself a second. So let's look at them individually. Right? Statement Q, we already said was true itself. Statement R, 9 is a prime number. We know that's false. It's divisible by 3. So the truth value Q or R, is that true or false?
It's true.
False or true?
It's true because when you use or, only one of them has to be true. When you use and, both of them has to be true. Okay? When you use the word or, only one of them has to be true. And I do have one of them true. Q is true. If one of them is true. Right. How about this one? I want the negation of Q. Does this mean and or? Okay. The negation of Q or the negation of R. I want true or false. Think about it a second. So first let's write out our statement. This says the negation of Q. Okay, because it says write a compound statement. So let's go ahead and write out the compound statement. Q is a cow has 12 legs, so the negation of Q would be a cow does not have 12 legs, right? Or the negation of R, a triangle has three sides, so it would be, or a triangle does not have three sides. So, since I use the word or, let's see. Since I use the word or, only one of them has to be true for the whole thing to be true. A cow does not have 12 legs, true or false? Well, that's true, right? Does not have 12 legs. A triangle does not have three sides. That part is false. But since it was a disjunction, the truth value of the whole thing is true, because only one of them is true. When you use the word or, only one of them has to be true for the whole thing to be true. When you use the word and, they both have to be true. Because it say it is either this or this true. It's true.
Hey, Mr. Roll, I didn't have to rewrite this, like, if one part is against the same negation of R. Obviously that's right. Why do you have to, like, say it's...
The negation of R is incorrect. R itself is correct, right?
Oh, okay.
Because R is a triangle has three sides. That's correct. The negation of R is false. Yes, what?
Are we gonna have to write these out on the homework?
Yeah, part of the problem is write the compound statement. That way I know you know what this means. The other section is a Venn diagram. Now, Venn diagrams are another way to show and or, right? Conjunctions and disjunctions. So this shows the number of students enrolled in a dance class. How many students are enrolled in all three? Where is that number on here? Right. The part that overlaps with everything is who's enrolled in all three. How many students are enrolled in tap or ballet? Now be careful here. This is a disjunction. It's the word or, right? I want tap or ballet. Could they be enrolled in both? Yeah. Could they be enrolled in all three? Yeah. Could they be enrolled in tap and jazz? Yeah, because I just want tap or ballet. Could they be enrolled in ballet and jazz? So to find tap or ballet, I would just have to add 28, 13, 17, 9, 29, 25. Because those people are enrolled in either tap or ballet. Because I said the word or. The only people that aren't are these 43 people who are only enrolled in jazz. So in this case, the number of people enrolled in tap or ballet would be 121 when you add up all of those. Because I said one or the other. I didn't have to say both. I said one or the other. How about here? Number of students who have these household pets. Another Venn diagram. I want to know how many students have one of the three type of pets. One or more. Okay. How would I find that answer? Well, that's all of these people have one or more, right? So I would just add them all up, and it would be 311. Because all of these people have one or more. Okay. That makes sense? Now, sometimes you see in a Venn diagram, there's a number like written out here. These people would be the ones that don't have any, right? But in this problem, there's not one there. How many students have dogs or cats? Again, these people have just dogs, so they would count. They would count. They would count. So would these three, right? Because they have dogs or cats. The only people that wouldn't count would be these 31 right here because they have just birds. When you add those together, you get 280. How many students have dogs, cats, and birds as pets? Now here I use the word and. Careful. It would be 10, right? Because I used the word and. I didn't say or. See the difference? If I would have said or, it would have been all of them. Since I said and, it's this one. The last thing we're going to talk about today is something called a truth table. Now, I can promise you on the Chapter 2 test and on the quiz next class, the very last problem is a truth table. I'll tell us that right now. And usually they're worth a little more than others. What a truth table is it lists all the possible scenarios you could have for a statement, okay, or for multiple statements. Meaning, okay, again, problem like this will be on the back of the first quiz and the back of the first test, okay, for this chapter. What it does is it lists all the possible scenarios. So this says make a truth table for not P. Does this mean and or and? Or Q. Not P or Q. You always start a truth table with the statements themselves, with P and Q. And what you do is you start listing all the possible scenarios that could happen. First, let's say they could both be true. It doesn't matter which order you start, but both of these could be true. They could also both be false. What's the other scenario that could happen? True, false. And what's the last scenario that could happen? False, true. So there's every scenario that could happen between these two statements. Now let's move to the next column because I want to find out what not P is. So if I'm looking right here, if P is true, what is not P, or the negation of P? True or false? It would be false, right? Because if P is true, not P would be false. All right, here I'm looking. If P is false, not P would be true. And again, if this confusion you, just put an example with it. Let's say P is the sky is blue. Well, if that's true, not P would be false. If the sky is blue is false, or if I said the sky is green, okay, that's false. The sky is not green would be true. The negation is just the opposite of whatever happened. So P is true, not P would be false. And P is false, so not P would be true. Again, your truth table might be in a different order. That's okay as long as it matches up. Now finally, I look in this column, because this is what I'm trying to find. I'm going to look at not P or Q. And since it's the word or, only one of them has to be true for the whole thing to be true. So when I'm looking at these two, would this be true or false?
True.
True, because one of them is true. Would this be true or false? True, because one of them is true. Would this be true or false? False, because both of them are false. Right. Would this be true or false? True, because both are true. So here are all the possible scenarios for not P or Q. If P and Q are both true, this is what would happen. If they're both false, this is what would happen. If P is true, this is what would happen. So, how did I get P? I started first with listing the possible combinations of P and Q. They could both be true. They could both be false. The first could be true, the second could be false, or the first could be false and the second could be true. That's the only combinations that could happen between those two statements. All right? You always start every truth table that way. You just go through and list every column. And then whatever column, some columns you don't need the negation. If the problem just asked for P or Q, I wouldn't have to write the negation. I would just move on to P or Q. But since this one asks for not P or Q, I put a not P column. Okay, so truth tables are all different sizes. We're going to look at a couple more that are pretty big. But they're all different sizes based on what it asks you to find. All right, let's look at another one here. Now, this one's huge. You won't be asked to do one like this because this would take a long time to list out every combination, right? It says construct a truth table for P or the negation of Q and R. It means do this part first because it's in parentheses. So you would have to go through and list every combination, P, Q, and R. They could all be true. They could all be false. The first true, the second false, the first one true, the second true, false, and so on, right? It'd take a while. So let's say you had one like this, and we did it for you. We gave you this much. We started first with every combination of P, Q, and R. They could all be true. These two could be true. These two could be true, and so on. I gave you every combination. And then I said P, what's this symbol? Or and. And P and Q. So to make that one, I looked at these two columns. I looked at P and Q. And since they were both true, that was true. Since that was the word and, one of these was false, so that one's false. Here, they were both true, so that one's true. And see how we finished that one? Same thing here. I looked at P and R. Well, they were both true, so P and R is true. They were both true, so P and R. That one's wrong. Yeah, that should be true. Because that's P and R. True, true. That's true. The fifth one is too? Yeah, this one right here. False and true. So the whole thing, since it's the word and, that is false. Any other mistakes? Yeah, those are mistakes. Good, that's it, I think. So now let's say we have a really kind of complex compound statement here. This says P and Q or P and R. So now I need to move on to looking at these two columns. Now this says the word or, right? So either this one has to be true or this one has to be true for the whole thing to be true. So let's look at these. They're both true. P and Q, so the first set of parentheses is true. The second set of parentheses is true. So what's my truth value here? True. And I would go through here. This one is false, but this one is true. So the whole thing would be true because I used the word or. That would be true, false, 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 false. And again, I got that by just comparing these two. Looking, since I used the word or, only one of them has to be true. Okay. So that's a really complex truth table. Most of the time, they're going to be 3, 4, maybe 5 columns at most. And I will almost always just give you 2 statements. I won't make you list out every combination of 3 possible statements. That makes sense? We're going to get some practice with those in just a sec. And again, this one's the same thing. We listed out everything, so you would look here. Okay. This says the word and, so both of these would have to be true for this to be true, because this is and. So I'm looking at P or Q, true. P or R, true. So this is true and this is true. That means this would be true, and so on. Okay, I would rather you get some practice with some smaller ones, though, on the assignment sheet. So that's the end of logic, this section.